Hello, grade 10. In today's lesson, we're going to be looking at pulses and waves approaching exam type questions, part 3. Now we have question 6. It says, two girls standing at opposite ends of a rope, each makes a pulse of the same speed. Pulse A with an amplitude of 4 centimeter moves to the right, and pulse B with an amplitude of negative 6 centimeter moves to the left. The pulses meet at point C. Now 6.1 says, state the phenomenon observed when the two pulses meet at point C. What is that phenomenon that we observe there? We say it is the superposition of pulses. Superposition of pulses is the algebraic sum of the amplitude of two pulses that occupy the same place at the same time. Nice. Now 6.2 says, draw a labeled diagram to show the resultant pulse when the two pulses meet at point C. Label the pulses clearly. Now let's see what we have got here. We have pulse A. Let's indicate that with the broken line. This is pulse A making an amplitude of positive 4 centimeter. Then it's moving that way. Then another broken line, a bigger amplitude now, indicating the pulse B, which has an amplitude of negative 6 centimeter, and it's moving to the left. Now, the resultant pulse will be, that's negative 2 centimeter. Remember, it will be, the direction of the pulse will be in the direction of the bigger pulse, right? So your resultant pulse will be negative 2 centimeter to the left. And that's how you show your resultant pulse, like that. So what do we have here? The interference that we have is obviously a destructive interference because it gave us a resultant pulse of a lower amplitude. Now 6.3 says, name the type of interference that takes place when the pulses meet. We've already said that. We said it's destructive interference. Destructive interference. Now, why we say it's destructive interference, you can see that A here shows a crest and B there shows a draw, right? Now, you will remember from our notes that we said if a pulse and if two pulses meet with a crest and a draw, we have a destructive interference. But if two pulses meet with a crest and a crest, we have constructive interference, since they will meet to form a pulse of a bigger amplitude. But when they meet with a crest and a draw, they form a pulse of a lower amplitude. 6.4 says, determine the resultant amplitude of the pulses at point C. So resultant, how are we going to calculate the resultant? So erase here. We have F resultant is equals to, let's say, the pulse made by A and the pulse made by B, right? So the pulse made by A is 4 centimeter, but the pulse made by B is negative 6 centimeter. Now the resultant will be negative 2 centimeter, which in other words means we have 2 centimeter to the left. So that's the magnitude of the resultant pulse. It's 2 centimeter, negative 2 centimeter. Now 6.5 says, how will the amplitude of pulse A be affected after passing point C. Write down only increase, decrease, or remain the same. Now you will note that after the pulse passes point C, it will go back to its original amplitude. So we say nothing will happen to the amplitude of pulse A, it will remain the same. So basically what we are saying here is we have a situation like this, whereby this pulse A will meet pulse B, and then they will give us our resultant pulse, which is in the direction of pulse B, so this is the resultant. But after they pass this point, what happens? Let's see. Now remember, we have our resultant. But after they pass that point, now this will be our B, still -6, and then this will be our A, still 4 centimeters. So nothing happens to the amplitude of the pulses after they coincide.